Hello everyone and welcome to Manage Engine Applications Manager free training series. Thank you all for taking the time and being with here today. We are in the third part of our free training series and today we will be discussing in detail about digital experience monitoring. Now, before moving into the agenda today, digital platforms such as websites and applications play a critical role in our everyday lives, whether it's ordering food, booking flight tickets, shopping online, or making financial transactions. We rely on these platforms to get things done quickly and seamlessly. Because of this, user expectations are higher than ever. If an application is slow, unavailable, or delivers a poor experience, users are likely to abandon it and switch to an alternative. And what happens to businesses? For businesses, this can directly impact customer satisfaction, brand reputation, and ultimately revenue. That's why delivering a great experience, great digital experience is no longer optional, but it's a business necessity. And that's why we are here today discuss about how you can leverage applications managers, digital experience monitoring features, and ensure your users, your end users are having great, consistent, great digital experience all throughout their life. So with this context in mind, let's take a look at the agenda for today. First, we'll be talking about how you can measure your website performance and changes in real time. Second, we'll talk about how you can proactively identify and resolve potential user impacting issues through synthetic monitoring or real browser monitoring. And number three, we'll talk about how you can analyze real user behavior patterns using the real user monitoring feature. Finally, we'll talk about how you can enhance web page performance and safeguard your brand reputation. So for a start, let's talk about the first topic, how you can measure website performance and changes in real time. Before that, we have a short stat here. According to an article published in BrowserStack, 47% of consumers expect a website to load in 2 seconds or less. And 40% of people abandon a website that takes more than 3 seconds to load. So what does this effectively convey? It says that even a 1 second delay in page response can result in 7% reduction in conversions. I underline 7% reduction in conversions. And that can translate into, say, millions of dollars of loss based on the margin you operate. Therefore, to avoid these kind of issues and to create seamless digital experience for users, website monitoring, website performance monitoring is essential. Not only does it provide insights into your website's availability, but it also gives you an understanding of critical metrics of your website so that you can work and improve its reliability. Now, the first step in digital experience is the interaction the user has with the website. But frequent downtime, slowness can make your site lose credibility among your loyal customers, as well as create a negative first impression amongst first-time visitors. So before fixing issues, it is important to understand what causes website downtime or slowness. So the first cause. First, we have the obvious and the mandatory scheduled maintenance, which is a temporary period during which a website or an application is made offline for updates, backups, or maintenance purposes. Then we have the data center problems or server issues. So if there is any issue with your server malfunctioning or hardware issues, the request from the user may not even reach the server. That again slows down your application and create a negative digital experience. Thirdly, there may be bugs in the code which may cause errors and prevent the site from loading or might cause slowness as well. And fourth, the website may be experiencing high traffic, especially if you don't have proper load balancing mechanisms. There might be a huge traffic surge and your applications may effectively slow down for many users. Fifth, most important and critical, there may be some hacking attempts made to the website. We've seen this time and again happen to major websites, major companies across the world. Hackers may try to pull any suspicious activity on the websites, which can cause the site to go down or effectively become slow. Finally, in few cases, your SSL certificate expires and that might cause issues among the users and they may not be able to trust your website anymore. So to prevent problems like this, we have the URL monitoring feature in Applications Manager. So why URL monitoring? First of all, it helps you to ensure the primary objective of keeping your website available 24/7. It acts as a continuous URL monitoring service and keeps a constant watch over your specific URL or a web page. Then it helps you get instant alerts or notifications whenever your site is down. And you'll also be able to validate HTTP requests and track website response time along with other important metrics such as DNS time, connection time, first byte time, so on and so forth. Effectively, what happens is that you'll be able to quickly diagnose the root cause of issues. And finally, you'll also be able to perform detailed content checks to ensure the availability of URLs. So let me take you to the UI itself and explain things further. So in the product, as you open, this is the screen that will greet you. Now, to add a URL monitor, all you need to do is click on New Monitor, Add New Monitor, and here you can basically see the different categories, the different monitors that are supported by Applications Manager. And the topic for right now is URL monitoring. So let's navigate to Web Server or Services. And here you have something called HTTPS URL. So click on this and it takes you to this particular page. So here provide the display name, the URL address, the web page you would like to monitor, and the polling interval, which is by default set to 5 minutes, but you can change based on your preferences. Provide the timeout value. You can also add advanced web monitors such as SSL or TLS monitors, DNS monitors, brand reputation, so on and so forth. And you can also configure for HTTP. So here, just provide the HTTP protocol, the pertinent protocol, and provide the form submission method, whether it is the post or the get. If it is post, you need to provide the payload type. And you can choose the request parameters, if any, provide the request parameters. And in here, you need to provide the authentication type. You could use the manual authentication, use below credentials and give the credentials here. Or if you had already configured credentials, you can select them from the predefined list, or you can use the SAML ADFS authentication method as well. Right. To add a new SAML authenticator, you can use this link. It takes you to a new page, this particular page. So here we have two components. One is the service provider and the other one is the ADFS, the Active Directory Federation service. So the first one, service provider details, provide the display name, simply a name for your SAML configuration inside Applications Manager. Then provide the redirect URL. This is the service provider's URL where the SAML authentication request is sent to begin the login process. Then we have the form submission method. Here you can choose how the authentication request is sent, either the get or the post method, and provide custom HTTPS headers if needed. If your identity provider requires any additional HTTP headers, you can specify them here. And yes, we have the SSL version. This option lets you choose the SSL or TLS protocol used for secure communication. And unless your environment has a specific requirement, it's best to leave this set to auto. And we have the form redirect option. Enable this option only if your authentication flow submits an HTML form instead of performing a normal redirect. So in that case, you can use this. And then we have the ADFS configurations, the sign-in URL. Now, sign-in URL is the login page of your ADFS server. So this is where Applications Manager redirects users to authenticate. Then you have the ADFS user credentials. Here provide the username and password of a valid ADFS account that Applications Manager can use during the authentication process. Then provide the username identifier. This field specifies the HTML name or the identifier of the username field on the ADFS page, and provide the password identifier as well. Then you have response binding. This setting determines how the identity provider sends the SAML response back to Application Manager. Now, post is the most commonly used and recommended option. And finally, you have the ACS, or the Assertion Consumer Service URL. Now, think of this as the endpoint in the Applications Manager module that receives the SAML assertion after successful login. So once the response reaches this URL, Applications Manager validates it and completes the authentication process. So basically, to configure SAML successfully, you will typically need these details from your identity administrator, such as your sign-in URL, your ACS URL, your redirect URL, and the valid ADFS credentials as well. So once these are entered correctly, Applications Manager can authenticate automatically while monitoring the URL. So once this authentication is done, you can move to the next field, which is error if response code. So this setting lets you define which HTTP response codes should be treated as failures. By default, a successful request returns 200 OK. So you can also use the comparison operators like greater than or less than to detect specific error conditions. So we have the retry immediate option. If this option is enabled, the Applications Manager will automatically retry the request as soon as an error is detected. And why this option is given is this helps you to eliminate false alarms caused by temporary network glitches or brief application interruptions. So here you can provide the user agent string that Application Manager uses when sending requests and the custom HTTPS headers if needed. And then you have the SSL version. Again, this option lets you choose the SSL or TLS protocol used for secure communication. If your web server requires mutual SSL authentication, enable this client certificate authentication required this option and provide the required client certificate details as well. Then we have the content check window, the section here. The content check feature actually helps you to verify a certain content is present on your web page or not. For example, we have should contain. So in the should contain field, enter a keyword or phrase that should always be present on the web page. Our Applications Manager will search the page for this particular text, and if it's not found, the monitor reports a failure. Right? For example, you might look for text like welcome or dashboard to confirm the page loaded successfully. So we also have the regular expression. If you need more flexibility, you can enable regular expression. This allows you to use regex patterns instead of plain text, making it easier to validate dynamic content or match multiple possible values. Then you have the should not contain. Here specify any text that should never appear on the page. This commonly is used to detect error messages such as page not found, internet service server error, or access denied, so on and so forth. You could also do case sensitive keyword search. By default, it is case insensitive. If you enable this option, if this option is enabled, Applications Manager will look for an exact match, including letter casing. Right? Then finally, associate this monitor to a particular monitor group if you had already configured one, or you can also create a custom monitor group and associate the same. Right? Then click on Add URL Monitor. The configuration is completed. So once this is done, you can find a URL monitor under Monitors tab. Let me click on the category view for easier access. And you have the web server or services here. As you scroll down, you have HTTPS URLs. So we have already pre-configured some monitors here. So let me take you to this particular monitor, and it gives you this page, the overview page, gives you basic details like the URL name, its availability status, when it was last polled, so on and so forth. As you scroll down, you get some more additional information like the response time. Now, if the response time is, say, it is slow or it takes longer for your website, then it means there is high latency, and a website with high latency generally leaves a negative impression amongst your customers. And fixing this response time will also help you to reduce the bounce rate. So for those reasons, monitoring response time is essential. And as you come down, you have in this table more metrics like the DNS time, the connection time, the first byte time, the last byte time. So basically the DNS time is the time taken to translate the domain name into an IP address. And the connection time is the time taken to establish the TCP or SSL connection with the web server. So high values here could indicate network latency, firewall delays, SSL handshake issues, or an overloaded web server. Then you have the first byte time. This is one of the most important metrics because it measures the time between sending the request and receiving the first byte of the server's response. So a high first byte time generally means the server is taking longer to process the request before it starts sending back the data. Right? Then you have the last byte time. This measures how long it takes to receive the entire response after the first byte arrives. Then as you scroll down, you have the page size. The page size metric tells you how much content is being returned by the web page. If the page size suddenly increases or decreases significantly, it could indicate missing content, an error page, or an unexpected change to the website, even if the URL is still accessible. So if you want to get alerts for these metrics, you could use the configure alarms option. It takes you to this particular page. For example, the monitor name is given here, but the attribute is the second important field. So attribute is basically the metric you're basically monitoring. Excuse me. And here you can associate the threshold, whether it is the threshold profile, the manual profile, or the adaptive profile. So we basically have two types. The threshold profile or the manual profile lets you define fixed values for, say, your warning or critical alarms, whereas the adaptive profile uses machine learning to learn normal behavior and automatically adjust the thresholds based on historical trends, reducing false alerts. So let me click on new threshold profile because I haven't created anything already. So provide a threshold name, and here you can provide the critical alarm. Say if the DNS time is more than 500 milliseconds, then raise a critical alarm. You can configure for that. You can also use the show advanced options, and it provides the warning alarm, the clear alarm as well. So the warning threshold acts as an early indication of a potential issue. For instance, you might generate a warning when DNS time exceeds, say, 300 milliseconds, allowing you to investigate before the condition becomes critical. So clear alarm is basically the clear condition. When this is met, the alarm is automatically cleared. For example, say if the DNS time drops below, say, 250 milliseconds, then Applications Manager clears the alert without requiring manual intervention. Then you can also configure for actions. Say if you want to raise a critical severity alarm, you can perform actions. So let me take you to this particular setup and show things further. So what it effectively does is that you can use that option and perform certain actions, like say you want to raise a critical alarm as a mail to a certain person, to a certain technician. You can do that, right? So those are the actions that you could perform. So here I'm not able to show the data. It's taking time to load. Well, I'll when it is loaded, I'll come back and show this. Let me take you to the presentation itself and move to the next topic. Now let's move on to the next topic, or the second topic for the day, which is to proactively identify and resolve potential user impacting issues through synthetic monitoring. Now, in today's age of instant gratification, end users expect to enjoy a seamless experience on your website. While URL monitoring does give you the website availability and response time, you cannot know if the users are being able to achieve their objectives, like completing the transactions or making a purchase without any failures, unless you understand the website's end user experience. Now, this is where the synthetic monitoring feature comes into picture. So synthetic transaction monitoring, also called as real browser monitoring, what it effectively does is that first and foremost, it will help you to analyze the website performance from an end user perspective. It helps you to test the performance of critical user parts by recording complex workflows. You can also dynamically track website availability and performance of your website from your end user's location. Finally, you'll also be able to ensure that your website is meeting business objectives and service level agreements. So, as I said earlier, synthetic monitoring is also called as real browser monitoring, and that's the name you'll find in the UI. Now, this actually allows you to test an actual user journey on your website or application, just like a real customer would do. For example, you can create a monitor for an e-commerce application for its workflow, such as, say, logging in, searching for a product, adding it to the cart, completing the checkout process, and finishing things successfully. So this entire process you can basically simulate using this synthetic monitoring option. So how does this work? The first step is to download and install an agent. The agent is basically called End User Monitoring Agent, or EUM agent. You can install this agent on the machines from which you want to monitor the application. And these could be your branch offices or customer locations across different geographic locations. Next, you use the web transaction recorder to record the business workflow you want to monitor. For example, on an e-commerce website, you can record the steps involved in searching for a product and placing an order, all those steps. Now, as you record the transaction, every action you perform, such as clicking a button, entering a text, or hovering over an element, or navigating between pages, is automatically converted into Selenium-based scripts. Applications Manager then opens a real browser such as Chrome or Firefox and periodically replays the recorded script to verify that the entire workflow is completed successfully. And if any step fails, it immediately detects the error. During every playback, Applications Manager collects performance data for each step and publishes the metrics on the monitoring dashboard. If an error occurs, it can also capture a screenshot of the browser, helping you see exactly what the user would have seen at the point of failure. And since the EUM agent can be deployed in multiple locations, you can monitor the same business transaction from different branch offices or geographical locations and compare the end user experience across all those locations. Now, here in this flow, we have just described the basic workflow of real browser monitoring. Again, the first step is, or the first prerequisite is to use the real browser monitoring feature is to install the EUM agent. Right? These agents can be installed in multiple branch offices, as you can see from this picture, or on different systems of your end users. All you need is a secured HTTP connection between the agent and your Applications Manager server. And the workflow is quite simple, as established earlier. You record the transaction using the web transaction recorder, deploy the agent wherever you want to monitor, and the agent will periodically replay the transaction in real browser. The collected metrics are sent back to Applications Manager, giving you a centralized picture of your application's performance across all locations. So back to the UI, and let me explain things further. So as I said earlier, the first step is to download and install the EUM agent. So we have a particular page here. It's called Applications Manager add-on. So you can just Google Applications Manager add-on and list it. This particular page will pop up, and it lists on basically all the add-ons that you need for the product for various features. So this was the monitoring agent I was talking about. So you can just use the download now button. It takes you to this particular page. Here you can download the pertinent version for your operating system based on the version, the Applications Manager version that you're using, and you can download and install the same. So during the process of installation, it will ask for an API key. So when it asks for an API key, you can very well come to the product, go to settings. We have integration with portals, click on REST API, and here you will have the API keys. So choose the end user monitoring, the EUM key. You can copy the key and paste it in the installation window and complete the process. So that is one part. Once that is done, you can come to the product and configure for real browser monitoring. So click on new monitor, add new monitor, and under web server or services, we have real browser monitoring. So here you just need to provide the website URL, choose the device type, and so basically I was talking about the recorder, the web transaction recorder. So I haven't installed this yet, but you can use this option. It will take you to the particular extensions page, and you can use this recorder and record the entire transaction. So that's step number 2. In step number 2, you need to record the entire workflow or the customer journey in your application or website. So once the process is done, there'll be a stop recording button right at the top. So you can use that and complete the recording process. And you can apply this monitor to a particular monitor group. That's the monitor configuration. Right? So once this process is done, you'll be able to find your RBM or real browser monitoring monitor under monitors, web server or services. As you scroll down, you have real browser monitoring, and there's already a monitor added here. So let me take you to this particular page. So here you will find all the details that is needed, right? So basically this gives a overview of the page of your particular website, and gives the health and availability, the availability timeline as well. So here you can see the each step, how much time it's taking. You can see those details. And let me click on the EOM agent here, and it takes you to this particular page where you can see more additional details, in-depth details, metrics like, say, your average page load time, your transaction time. Now this particular graph, the page load time, shows the average time taken for the web page to completely load during each execution of the transaction. Now, if you notice a sudden increase here, it means users are experiencing a slower page than usual. Then you have the transaction time. This represents the total time taken to complete the entire recorded business transaction. For example, if you have recorded an e-commerce checkout process, the transaction time includes every step from opening the website, logging in, searching for a product, adding it to the cart, and completing the checkout process. Again, if this metric increases, it means one or more steps in the workflow are taking longer than expected. Then you have the page load time for each step. Instead of showing only the total transaction time, it breaks down the transactions down by step, like step 1, step 2, so on and so forth, and display the page load time for each recorded step. Say, for example, in your e-commerce example, it's login, search for the product, add to cart, and finally checkout. This makes troubleshooting much easier because you can immediately identify the bottleneck instead of investigating the entire transaction. And while adding the monitor for real browser monitoring, we also have another method. So let me explain that as well. Can once again go to add new monitor, web server or services, and yes, real browser monitoring. So here, this is record using the web transaction recorder. That's one method. You also have the import Selenium script method. Right? So here you can just provide the display name as you want, and you can upload the Selenium ID test case that you have. Now, Applications Manager currently supports Selenium scripts in HTML and JSON formats. Then you can provide the page load time. This specifies how long Applications Manager should wait for a page to load before considering the step has failed. The default is set to 60 seconds, but you can increase it for slower applications if needed. Then we have think time. Think time is the delay inserted between consecutive actions during playback. This helps you simulate more realistic user behavior instead of executing every step instantly. Then shows screenshot. When this option is enabled, Applications Manager basically captures a screenshot at every step of the transaction. These screenshots are extremely helpful when troubleshooting playback failures. And you can also use this, enable this show performance metrics. When you enable this, if you'd like to collect detailed performance metrics for each page load, such as load times, browser times, in addition to simply checking the transaction, you can use this option as well. And if your application uses a self-signed or expired SSL certificate, enable this option to allow the browser to proceed instead of failing the playback. Right? Finally, set the polling interval as per your needs, and you could again associate this to a particular monitor group. Then you could also, if you had installed the agent, if you have the end user monitoring add-on, you can execute this browser transaction for one or more locations. Right? This allows you to simulate user experience across different geographic locations. So finally, you can test this and save, and you can also use this method for adding your real browser monitors. Now, let us see some of the real-time use cases for synthetic transaction monitoring. First thing is you can compare your performance to your competitors. You can monitor your website alongside competitor websites and compare metrics such as page load time and response time. Now, this will help you to understand where you stand and identify opportunities to improve the user experience. Secondly, you can test new features. You can record and replay critical user journeys after deploying any new feature or updates. This ensures important workflows such as login or checkout continue to function correctly even before users encounter any issues. And thirdly, you can assess the performance of third-party applications. Many applications today, they rely on external services like payment gateways, identity providers, or APIs. Now, real browser monitoring helps you measure how these third-party components affect your application's overall performance and end-user experience. Finally, you can find issues before customers do. You can run synthetic transactions at regular intervals to proactively detect slowdowns, broken workflows, or application errors. Again, this helps you to, or rather helps your teams to proactively resolve issues before they impact end users. So before moving to the third topic, I would like to convey that we are running a poll right now. So if you want to get a personalized demo of our solution of Applications Manager, you can participate in the poll, and you can click yes in the poll, and we'll be able to reach you out and facilitate the personalized demo. So I encourage you to participate in the poll as well. So moving on, the third topic for today is analyze real user behavior patterns to gain insights into front-end performance. Excuse me. As businesses go digital and global, their websites are accessed from various devices from multiple geographies. Now, in this context, it is important to provide a consistent user experience across all geographies and devices. But in reality, the user experience could be impacted by various external factors. This could be network latency, operational hiccups, trouble retrieving requests, slow ISPs, and many more. Also, what works in one particular browser may not work in the other browser. And we've seen this time and again happening even in our own lives as well. One particular website or application will work in one particular web browser, say Chrome, but will not work in something like Firefox or Microsoft Edge. So to address issues like this, we have the real user monitoring feature. So first of all, what is real user monitoring? Now think of real user monitoring as seeing your website through your user's eyes. It captures how real visitors interact with your website, how quickly pages load, and where they experience delay, so you can identify and fix issues that impact their performance or experience. So how does RUM or real user monitoring actually work? To facilitate data collection and reporting, first of all, you need to download and install our DEM or Digital Experience Monitoring Agent. Previously, it was known as RUM agent, but now in the product, we have updated this. It's called the DEM agent or the DEM collector. The DEM agent is then deployed on the server where the web application is hosted. Following that, you need to insert a small JavaScript snippet generated by Applications Manager on the header or footer part of the HTML code of the website that you want to track. If you wish to monitor the web application, you will need to insert the code in the common or index page of the web application that needs to be monitored. Right? So once this process is done, once you copy and paste the JavaScript, when a user opens the web page, the JavaScript snippet begins collecting performance metrics in the background. It sends this information to the DEM agent, which then passes it to the Applications Manager, where you can find all the data. So this is how basically it works. And what are the capabilities, or how can you leverage real user monitoring? First of all, it helps you to analyze the front-end performance across several geographies. You will also be able to analyze the front-end performance based on ISPs, browsers, and devices to ensure hassle-free digital experience. You'll also be able to measure end-user satisfaction. You'll also be able to isolate web transactions that contribute to poor user experience. And you can also gain comprehensive insights into domain resources and user sessions. Additionally, you'll also be able to identify JavaScript errors instantly, which will prevent users from reporting service errors. Finally, you'll also be able to analyze and compare the impact of any new changes that have taken place in your web application. So in the product, before configuring for real user monitoring, you need to download the agent which I was talking about. So basically, you can come to this page, the add-ons page, which I was talking about earlier. We have the real user monitoring add-on. So basically, it's now called the DEM collector. You can click download now, takes you to this particular page. So it's formerly, it was known as RUM agent, but now it's DEM collector. And you can download the compatible version for your OS and for your applications manager version. Then you can continue with the installation process. Again, during the installation process, it will ask for a certain API key. We can take the API key from the product, you can go to settings, integration with portals, you have REST API here. And yeah, we have the DEM collector. You can just copy this and paste it and complete the installation process. So once the installation process is completed, come back to the product, you can click on new monitor, add new monitor, and I believe by now you'll be very much familiar with the UI, and you can come to web server or services, and right next to real browser monitoring, you have real user monitor. Click on this and just provide the basic details such as the website URL and provide a monitor name for this. And here you need to provide the threshold value for the AppDex score. So what is AppDex score? AppDex score basically tells you the user satisfaction levels. So more about this when I take you to the monitor page itself, but basically it tells you the user satisfaction level. So I'm giving the threshold as 2000 millisecond. So say if it crosses 2000 and between 2000 and 8000, that band, the users are having a kind of a neutral or tolerating experience. When it crosses 8000 millisecond, then it means that users are having bad experience, right? Consider you opening your net banking or mobile banking website or application, and it continuously takes more than 3, 4, 5 seconds to load. You become irritated, right? So to understand or gauge the user experience, that pulse, we have given this AppDex score. So you can then click on next, and here you can, once the installation is done, the DEM collector installation is done, you can choose the DEM collector that you've installed, and then click on next. And the next page, you need to choose the code based on which the website or the application is running, say Java code or whatever it may be, pertinent to your application. Once that is done, a JavaScript snippet will be generated in the applications manager screen. So that will look something like this. So you can copy the script and paste it in the header or the footer part of your website, and that's how real user monitoring starts to work, right? So once all this configuration is done, again, go to monitors, web server or services. As you scroll down, you have real user monitor. Yeah, so let me click on this, and it takes you to this overview page where you get availability details. And let me go to the summary page. It gives you additional details, more important metrics like your average response time, your page views, the error count, and here you have the AppDex score, which I was talking about earlier. So this tells you, in terms of percentage, tells you how much percentage of your users are happy with your website or your application, and how much percentage of your users are tolerating or kind of having a neutral experience, and how many are totally frustrated or unhappy with your website, right? So overall score is 0.65 as per this example. So this again helps you to gauge the user experience, what they are feeling right now, right? It's a simple metric, a single metric, but gives a nutshell of what's happening with your users. Now, as you scroll down, you'll find more additional details here. So in this graph, you'll be able to see the AppDex score based on the regions. For example, in in India, or say parts of Russia or America, North America, South America, people are happy with your solution, which means it'll be represented in green color. But say when it comes to Australia, people are having a neutral experience, a tolerating experience, then Australia will be populated in yellow or orange, right? So that's how you can gauge how users in a particular location, whether they are happy or not using your website or application, right? Then you have the response time here and more important metrics in the form of a graph, such as your page views and throughput. Then moving on, we have the geographic tab. Again, this tab, it gives you the same data in the form of a graph. Here you also have a table which represents each region, say Australia or any particular country like India, USA, and the AppDex score for that particular region, the average response time for that region, the page views and throughput. So the same data you can find in the form of a table as well, and quickly understand in which particular region users are facing trouble, and you can narrow down to the issue, focus on that particular region, talk to the technicians over there, and get your issues sorted very quickly. And then we have the ISP tab. Again, in this tab, you'll basically get a graphical representation of the data. I'm not able to show data right now, but you'll see the different ISPs and how much response time each ISP is taking, so you can quickly, contact the ISP and fix the issue. Then you have the browser data, the browser tab here. Here we can see the response time across different browsers over time. Now, say for example, Chrome users are experiencing highest response time in this example, right? So this helps developers in your team determine whether performance issues are limited to a specific browser or does it affect all users, right? As you scroll down, the same data you have in the form of a table as well, the browser name, the average response time taken by each browser, the total users connected to it, the throughput. Then we have the device type tab. Again, this will let you know, this will provide a chart which lets you know in each operating system how is your website or your application performing. So you can understand the performance of the application based on each OS, say Mac OS or Windows, and you can optimize your performance for the same. Right. Now, the web pages tab, this report lets us drill down to each page level. We can immediately identify which URLs are taking the longest time to load, how many users are accessing them, whether factors like, say, page size or traffic volumes are contributing to the delay. Again, this helps your IT teams to focus on optimizing the pages that have the biggest impact on end user experience. Then we have the user sessions tab. The user sessions tab provides insight into individual user visits, like who is accessing from what browser, which device they are accessing from, and which country. This helps you to analyze user behavior and troubleshoot issues experienced by specific users. Then we have the resources tab. The resources tab basically breaks down the resources loaded by your application into first-party resources, third-party resources, and CDN resources. So it shows the response time, the resource size, and the request count, helping you identify which resources are slowing down page loads. This enables you to optimize both your assets and your external dependencies. So moving on to the AJAX calls tab. This report lists all the AJAX requests made by the application, their performance metrics, such as the average response time, the total count, throughput, the average resource size. It shows how quickly each background request is processed, how often it's called, and the amount of data transferred. This helps you identify slow backend APIs that may impact end user experience. This way, you'll be able to get a holistic picture of your website, of how your website is performing from the lens of a real user, and optimize the performance. Right? Finally, we have the JavaScript errors. So if any JavaScript errors are thrown, basically it's a Java applications, and you can see the errors, again, pointed in the form of a graph. Right? So this is all about real user monitoring. Now, to understand real user monitoring in a better way, we need to talk about the limitations of synthetic transaction monitoring. Now, synthetic transaction monitoring does not always align with reality. Since the nature of traffic used for synthetic testing is not organic but synthetic, it isn't truly representative of a real user experience at any given time. Secondly, it consumes a lot of time for incident resolution. When you receive complaints from end users in real time, synthetic monitoring will not tell you what exactly the issue the end user was facing. So you would have to painstakingly analyze the performance of every business critical transaction and create scripts for synthetic testing in order to uncover possible issues. Thirdly, you will only be able to get a narrow view of performance. Since you are not monitoring the actual users, you aren't really getting an idea of how your website is used in real world. So all you have is simply a narrow view of your website performance. But together, when you use synthetic monitoring and real user monitoring, they can complement each other and actually make things very effective for you. So first thing is correlating business with performance. So real browser monitoring tells you whether a business transaction is working as expected, while RUM or real user monitoring shows how real users are actually experiencing it. Suppose, say, for example, you have recorded the checkout process on an e-commerce website using real browser monitoring. Now, real browser monitoring reports that the checkout completes successfully in 5 seconds. However, RUM or real user monitoring shows that real users in Singapore are taking 12 seconds to complete the same checkout process because of network latency. So together, you know that the application is healthy, but together, using both the features, you will understand how users in particular certain regions are actually, facing what they are actually facing with respect to your application. Then you can identify problems even before active users arrive. Real browser monitoring continuously tests your application even when no one is using it, while real user monitoring starts collecting data only after real users visit a website. So real browser monitoring acts as an early warning system, while RUM or real user monitoring validates the actual user experience once traffic begins. And thirdly, you'll be able to troubleshoot outages. So say, for example, when users report a problem, real browser monitoring helps determine whether the issue is with the application itself, and real user monitoring helps identify who is affected and where. Right? So by combining both, you quickly narrow down the root cause instead of investigating the complete application layer. So that's the benefit of using synthetic transaction monitoring and RUM or real user monitoring together. So having said that, let's proceed to the fourth topic for today, which is to enhance web page performance to safeguard your brand reputation. So the first feature we have in this section is the web page analyzer. Now, what is web page analyzer? Now, think of web page analyzer as a diagnostic tool for a web page. Instead of telling you that a page is slow, it shows you exactly what's making it slow, whether it's large images, slow JavaScript, or render blocking CSS, or any third-party resources. This helps developers optimize the page for faster load times and better end-user experience. So using web page analyzer, you'll be able to track the response time, the domain summary. You'll also be able to gain page speed scores and suggestions. You'll also be able to perform request tracking with a waterfall chart, which I'll show you in the UI. And you'll also be able to manage the SSL certificates of your web page as well. So back to the UI. Again, for web page analyzer, you need to download an add-on for that. So in this add-ons page, we have the web page analyzer add-on. Click on this button. It takes you to this page. Choose the version that is most compatible to your operating system and your applications manager build. Download it. And after the download is complete, create a folder called WPA add-ons and place it under applications manager home or the working directory and extract the contents. So once this part is done, you can move to the UI and so you can move to the UI again, go to new monitor, add new monitor. Under web server of services, you have web page analyzer. So you see that most of our DEM or digital experience monitoring features are available under web server or services. So you can find them here. So go to web page analyzer, and here just provide the display name, the web page URL that you wish to monitor, excuse me, and provide the page load time and the wait after load and the HTTP method that you wish to use, and provide the custom HTTPS headers, the username and password, and if there are any domains to block. You can also add content check for response, provide the regex content, or you can provide a certain specific content and it can monitor for that specific content in your web page. And yes, vice versa also, if you don't want to see certain content like page not found, you can use that here. And you can do case sensitive keyword search as well if needed. You can also enable SSL or TLS certificate monitoring. And finally, set the polling interval, which is usually set to 30 minutes, and test the credentials. So finally, once this is done, you can select the monitor group that you wish to associate this monitor with, or you can create a new monitor group, a custom monitor group based on your needs. So once this is done, you can go to Monitors tab, Web Server Services. As you scroll down towards the bottom, we have Web Page Analyzer. So here's already added monitor here. Now, as you scroll down, you'll find basic details like the availability, the basic URL, what's the URL that's being monitored, the page load time, the total number of requests, the page score, overall page score, so on and so forth. And as you scroll down, you have the more important metrics such as the response time given in the form of a graph. So here you have metrics like the DNS time. It measures how long it takes to translate the website's domain name into an IP address. The connection time, it measures the time required to establish a connection between the browser and the web server. And you have the first byte time. It basically measures how long the server takes to process the request and send back the first byte of data to the browser. You have the start render time. It measures when the browser begins displaying the first visible content of the web page to the user. The document complete, it measures the time taken for the web page and its dependent resources to finish loading, indicating that the page is ready for interaction. Then you have the page load time, which was already present above as well. So it tells you the total time for the web page to load completely from start to finish. Right? So you have the domain name, the IP address, the total number of requests for each domain, the average response time, and the associated metrics as well on this page. And as you move to the network log or the waterfall chart, which I was talking about, this waterfall chart will give you a visual representation of the critical metrics related to each transaction, which helps you identify components that are loading slowly. And using this, you can prevent website downtime and slowness and help the website to perform optimally. And here you can use the, if you're monitoring for SSL or TLS certificates, you can use this window or this tab, provides the details like what's the common name, issued by authority, and its validity, which is very important. You can know when this particular certificate expires, so on and so forth. Now, the resource details tab, this tab breaks down your web page into individual resource types. For each category, you can see how many requests are made, how much data is downloaded. For example, say if JavaScript contributes the largest number of requests or page sizes, then you may want to minimize the script, remove unused code, and that way you can, optimize your page performance. So here you will find the screenshot as well of your web page, and you can see how it is actually loading and fix things by taking the screenshot and by viewing things on the screenshot. Then you have the Page Insights tab. Now, this tab, this Page Insights tab, evaluates your web page against industry standard performance best practices and assigns each rule a grade from A to D. A means excellent and D means it needs improvement. So this gives you an instant view of what's well optimized and what requires attention. You can also drill down into any role to see the exact files or resources contributing to the issue, making it easy for developers to prioritize and fix performance bottlenecks. So this is how Web Page Analyzer feature works in Applications Manager. Let's move to the presentation itself. And the next feature that's for discussion is the Brand Reputation Monitor. Now, as the title suggests, this helps you maintain the reputation of a particular website. This feature will track and ensure that your brand reputation is maintained by preventing your website from being blacklisted. You will also be able to get insights whether the website is identified as suspected, malware, phishing, deceptive, or an unwanted software. You'll also get immediately notified if any of our web pages are marked as unsafe. So in the product, you can find this under monitor, add new monitor. So again, web server services, and here in the first row, you'll find this brand reputation monitor feature. So provide the display name, the web page URL that you wish to monitor, and check its connectivity. Then you can associate this to a particular monitor group if needed, and then click on Add Monitor. So once this is done, go to Monitors, Web Server Services. Number 3 is Brand Reputation. So it takes you to this particular page, and you can find basic details such as your availability and your performance stats. So as you scroll down, this section, the brand reputation count, this provides a quick summary of the website's security status. So malware count, it shows how many monitored websites have been flagged for distributing malware. And phishing or deceptive count indicates websites suspected of phishing or trying to steal user credentials. And thirdly, the unwanted software count, it shows websites that are serving unwanted or potentially harmful software. And we have the brand reputation details here, the display name, you get the web page URL, and the suspected as malware indicates whether Google has identified this website as distributing malware. The same metric, suspected as phishing or deceptive, shows if the website is suspected for hosting phishing or deceptive content. And finally, this particular metric, suspected as unwanted software, indicates whether the website distributes unwanted software. So basically, the green shield means the website is safe, while the red warning icon indicates that the website has been flagged as a potential threat. So moving on, we have the next feature, which is WebSocket Monitor. Now, Applications Manager helps you monitor WebSocket connections for availability, performance, and message integrity. And this helps you to ensure high availability, low latency, and seamless user experiences across your WebSocket-enabled services. So you'll be able to gain a comprehensive view of your WebSocket health. You'll be able to validate WebSocket message content and be notified when important metrics like handshake timeouts, connection delays occur. So back to the UI itself, and again, in the product, you can find this under New Monitor, Add New Monitors, Web Server Services, and towards the bottom, you have WebSocket. So here, just provide the display name, the WebSocket URL, the timeout in seconds, the credential details. You can use manual authentication method by providing the username and password, or if you had already configured for credentials, you can select them from the drop-down menu, or you can provide a OAuth or OAuth token from any OAuth provider or a web token and complete the authentication configuration, then provide the custom HTTPS headers, the payload message if needed, and also add content, check for response. Then you can set the polling interval. This is usually set to 5 minutes. Finally, test the credentials and associate this to a particular monitor group. So once that is done, click on Add Monitor, and you'll be able to find your WebSocket monitors under Monitors, Web Server Services. Towards the bottom, you have WebSocket. So it takes you to the overview page. where you find availability, the performance stats, and as you scroll down, the response time details are present here. This is the overall time taken for the WebSocket to complete from initiating the connection until the expected response is received. Then you have the connection time. This measures the time taken to establish the initial TCP connection with the WebSocket server. You have the SSL or TLS handshake time. If your WebSocket uses a secure connection, this metric measures the time taken to complete SSL or TLS handshake before communication begins. Then you have the WebSocket handshake time. So once the TCP and SSL connections are established, the client sends a request to upgrade the HTTP connection to a WebSocket connection. So this measures the time taken to complete that WebSocket handshake. Moving on, the next feature, the final feature we're going to talk about is the SSL certificate monitoring. Now, managing SSL or TLS certificates manually can be challenging, especially when you have certificates spread across multiple servers and applications. Now, Applications Manager simplifies this by automatically monitoring all your certificates from a single place. It keeps track of important details like the certificate's validity, issuing authority, expiration date, and the number of days left before it expires. You can also configure threshold-based alerts so you'll be notified well in advance and can renew certificates before they expire. So in the product, you can find this under Add New Monitor, Web Server Services. You can choose SSL or TLS certificate monitor. So provide the display name, the domain, and the port details, and choose the protocol, the suitable protocol. And you can, if you need a proxy to connect to the domain, you can choose that as well. So you can ignore certificate name mismatch error, which is not recommended to ignore. But if you need, you could do that as well. You can also ignore invalid root and intermediate certificate. You can perform trust validation, check for blacklisted certificates, and finally, you can also ignore self-signed certificate check as well. Again, this is also not a recommended option to ensure a proper and a strong security posture. Then provide the timeout in seconds, the polling interval, and test the credentials, and you can associate this to a particular monitor group. So then go to monitors, web server services. As you scroll down, you have SSL or TLS certificate monitor. Yeah, let me click on this, and it gives you the availability health status. So we have then the certificate chain summary. Now this section provides a summary of the complete SSL or TLS certificate chain. As you can see, the certificate order column, it lists the server certificate along with the intermediate certificates that form the chain of trust. The common name tells you which domain or host name each certificate has been issued for, while the issued by column displays the certificate authority that issued the certificate. So you can also find the days to expire, the expiry status, the current status as well. And you can configure alarms for the same, keep thresholds, and get notified so that your SSL certificates are never expired before you know. Then you have the important tab, which is called the Cipher tab. Now, while the previous tab focused on the certificate validity, the expiry, this tab evaluates the security posture of SSL or TLS configuration itself. It helps you to determine whether your web server is using strong encryption standards and is protected against SSL or TLS vulnerabilities. Now, at the top, you'll see the overall grade, which provides a quick assessment of your SSL or TLS configuration. A higher grade, say such as A+, indicates that the server is configured with strong encryption practices. Then you have the trust checks, the vulnerability status section, which verifies whether the industry standard, whether your website is actually vulnerable or not. So it actually compares it against industry standards such as BEAST, Robot, Crime, and a green check mark indicates that your server is secure against these vulnerabilities, whereas a red indicates that a potential security risk that should be addressed. Finally, we have the secure cryptographic components section, and this verifies whether modern cryptographic features such as forward secrecy, AEAD are enabled. These components help ensure stronger encryption, better protection of transmitted data, and improved resistance against cryptographic attacks. Overall, the Cipher Details tab helps you validate that your SSL or TLS implementation not only uses a valid certificate, but also follows a very strong security best practices and ensures a stronger security posture. So before we conclude, I'd like to invite you to our free database performance monitoring webinar. So if you are a DBA or managing databases, this session will show you how to troubleshoot slow queries, identify locking and fail jobs, and proactively prevent performance issues using Applications Manager. The webinar is actually happening in 2 time zones. One is 6 a.m. GMT, the other one is 11 a.m. EDT. So you can join whichever works for your time zone, and we hope to see you there. To make things easier for you, we have enabled a quick poll for this. So just select yes if you'd like to register for the webinar, and we'll facilitate the registration process. Now let's have a quick recap of the topics that we discussed today. First, we discussed how we can monitor individual URLs for better user experience. Then we discussed how we can analyze the issues faced in critical workflows. Then we saw how synthetic transaction monitoring will help you go beyond the app-only view, and how RUM beautifully complements it with and helps you effectively achieve a wonderful digital experience for your users. Lastly, we saw how you can optimize web page performance using Web Page Analyzer and Brand Reputation Monitor. Thank you for tuning into today's session, and I look forward to see you in the upcoming sessions as well. The webinar session will be active for a few moments, and in case you have any doubts, you could just drop them in the chat window, and our panel members would be happy to answer them. We've also enabled a quick poll, and you can participate in the poll and give us your feedback about the presentation, the entire experience of this presentation, and for the presenter as well. Thank you.